Welcome back to our channel, where we delve deep into the mysteries and wonders of our universe. Today, we're focusing on one of the most powerful and terrifying natural phenomena on Earth, the Yellowstone Supervolcano. This isn't just a geological marvel, it's a potential global catastrophe waiting to happen. So, buckle up as we explore the incredible facts and recent developments that have increased the eruption risk by a staggering 320%. Picture yourself standing at the edge of an ancient, powerful force capable of reshaping continents. That's exactly what Yellowstone National Park conceals beneath its surface. A supervolcano, a true continent killer. For years, we thought of Yellowstone as just a breathtaking collection of hot springs and geysers. But in reality, it's the caldera of a supervolcano, a sleeping giant that has the potential to unleash devastation on an unimaginable scale. Our journey begins with the understanding of what a supervolcano really is. Unlike typical volcanoes, supervolcanoes can eject more than 1,000 cubic kilometers of material in a single eruption, causing global climate changes and long-term impacts on the environment. The term supervolcano might sound like something out of a science fiction movie, but it's a very real threat. The Yellowstone Supervolcano has erupted 3 times in the past 2.1 million years, and each eruption has had a profound impact on the planet. In recent years, a startling phenomenon has been observed. A 100-foot wide crack has appeared under Yellowstone, a clear warning sign that the supervolcano beneath is far from dormant. This fissure has drastically amplified the eruption risk, making it a pressing concern. Scientists have been closely monitoring changes in the Norris Geyser Basin, a blistering region with thermal features dating back an astonishing 115,000 years. Here, temperatures soar to a jaw-dropping 459 degree F just 1,000 feet below the surface. But what does this crack signify? It's a manifestation of the immense pressure building beneath the surface. The Earth's crust is literally being torn apart, indicating that the magma chamber below is restless. This crack is not just a geological curiosity, it's a potential harbinger of a catastrophic event. The increased seismic activity around this crack suggests that the supervolcano is preparing for a significant geological shift. One of the most fascinating indicators of Yellowstone's volatile nature is the Steamboat Geyser. This towering geyser, once an unpredictable spectacle, has now become a frequent powerhouse, erupting as often as once a week since March 2018. These frequent eruptions raise the question: is Steamboat's newfound activity linked to the increased eruption risk? Could this be the prelude to a more significant event? The Steamboat Geyser's increased activity is not just an anomaly, it's a signal that the underground plumbing system is undergoing significant changes. The geyser's eruptions are powered by the same geothermal forces that drive the supervolcano. The fact that Steamboat is erupting more frequently could indicate that pressure is building in the magma chamber, pushing steam and hot water to the surface more often. From 1996 to 2014, the ground in the Norris Geyser Basin has risen and fallen in dramatic fashion. This rhythmic dance of the Earth, coupled with a significant 4.9 magnitude earthquake in 2014, has stalled and resumed uplift patterns. As of 2019, the ground has been steadily sinking, but it remains 5 inches higher than it was in 2000. Could these movements be a precursor to a more significant event? The Earth itself seems to be giving us signals, and scientists are racing against time to decipher them. These movements are caused by the inflation and deflation of the magma chamber beneath Yellowstone. When magma enters the chamber, the ground above it rises. When magma leaves the chamber, the ground sinks. This cycle of inflation and deflation can create significant stresses in the Earth's crust, potentially leading to earthquakes and fissures. The 4.9 magnitude earthquake in 2014 was a stark reminder of the forces at play beneath Yellowstone. A supervolcano eruption under Yellowstone would be unlike anything humanity has ever witnessed. Such an event would spew vast amounts of toxic gas, ash, and volcanic dust into the atmosphere, potentially causing a mini ice age and catastrophic agricultural failures. The last major eruption, 640,000 years ago, left a 34 by 50 mile depression in the ground, And the next one could be even more devastating. Imagine entire states blanketed in ash, crops failing, and the sun blocked out for years, plunging the world into a volcanic winter. The ash from a Yellowstone eruption would be particularly devastating. Volcanic ash is composed of tiny, sharp particles of rock and glass that can travel hundreds of miles from the eruption site. This ash would blanket everything in its path, collapsing buildings, smothering crops, and contaminating water supplies. The release of sulfur dioxide into the atmosphere would create acid rain and contribute to global cooling, potentially triggering a volcanic winter that could last for years. Recent research has revealed the complex structure beneath Yellowstone, including 2 sizable magma chambers stacked on top of each other. This discovery is crucial in understanding how magma rises and the potential for a significant eruption. Geologists have used seismic wave data to create detailed images of these magma chambers, revealing the frightening potential for future activity. The upper magma chamber, located about 3 to 6 miles beneath the surface, contains mostly solid rock with pockets of molten material. Below it, at depths of 12 to 30 miles, lies the lower magma chamber, which is much larger and contains more molten material. These 2 chambers are connected by a network of conduits through which magma can travel. Understanding the dynamics of this system is key to predicting future eruptions. The impact of a supervolcano eruption would not be confined to the United States. The ash cloud could circle the globe, affecting climates worldwide, disrupting air travel, and causing a humanitarian crisis on an unprecedented scale. Countries around the world would feel the shockwaves of this eruption, both literally and figuratively. The economic and environmental fallout would be immense, reshaping our world in ways we can scarcely imagine. A supervolcano eruption would have far-reaching consequences. The ash cloud would disrupt global weather patterns, leading to crop failures and food shortages. Air travel would be severely impacted, with flights grounded due to ash in the atmosphere. The global economy would suffer as supply chains are disrupted and trade grinds to a halt. The social and political ramifications would be profound, potentially leading to mass migrations and conflicts over resources. Looking back at history, we can see the catastrophic potential of supervolcanoes. The eruption of Mount Tambora in 1815, though not a supervolcano, caused the year without a summer, leading to widespread famine and death. The Toba eruption 74,000 years ago is believed to have nearly driven humanity to extinction. These events are stark reminders of the destructive power that lies beneath our feet. The Toba eruption is particularly significant because it provides a glimpse into the potential impact of a supervolcano eruption on human civilization. The eruption released an estimated 2,800 cubic kilometers of material, creating a global volcanic winter that lasted for several years. The resulting drop in temperatures led to a dramatic reduction in the human population, with some estimates suggesting that only a few thousand individuals survived. To truly grasp the threat posed by Yellowstone, we need to understand the science behind supervolcanoes. These geological giants are formed when magma from the mantle rises into the crust, but is unable to break through the surface. Over time, pressure builds as more magma accumulates, creating a massive magma chamber. When the pressure becomes too great, the crust fractures, leading to a catastrophic eruption. Supervolcanoes differ from regular volcanoes in several key ways. Their eruptions are much larger and more explosive, capable of ejecting vast quantities of material into the atmosphere. The magma they produce is often more viscous, trapping gases and creating more explosive eruptions. Understanding these processes is essential for predicting future eruptions and mitigating their impact. While the likelihood of a supervolcano eruption at Yellowstone remains low, it's crucial to be prepared. Scientists are continuously monitoring the park for signs of increased activity, using a network of seismometers, GPS stations, and other instruments to track changes in the magma chamber. This constant vigilance is our best defense against a potential disaster. In addition to scientific monitoring, there are practical steps that can be taken to prepare for an eruption. Emergency plans should be in place to evacuate affected areas, and supplies of food, water, and medical equipment should be stockpiled. Public education campaigns can help people understand the risks and how to respond in the event of an eruption. The Yellowstone Supervolcano remains one of the most closely watched geological features on Earth. While the likelihood of an eruption remains low, the consequences would be catastrophic. As scientists continue to study and monitor Yellowstone, one thing is clear: we must remain vigilant. What do you think about the 320% increase in the eruption risk at Yellowstone? Could this sleeping giant awaken in our lifetime? Share your thoughts and questions in the comments below. And if you enjoyed this deep dive into one of nature's most powerful forces, don't forget to like, subscribe, and hit the bell icon for more exciting and informative content. Stay curious, and we'll see you in the next video.